Okay, welcome back, everybody, to our brand new Unit 10, circles. I will let you know just from past experience, this is probably one of the hardest units that we'll do all year, and we're doing it remotely, which makes it the difficulty level increase a little bit. And the only reason I say it's difficult, because kids have trouble remembering all the vocabulary. You will see a lot of new vocabulary terms starting today that maybe you were not exposed to at the middle school. All right, so this is going to be a long unit. I'm hoping we finish this unit together face to face, and a lot of vocabulary, so I'm hoping we keep it straight. Okay, so let's jump right in here. First, want to just make sure we know different parts of the circle. I'm going to introduce 3 parts of the circle, 2 of which probably you have already heard of. First, before we get to those 3 parts of a circle, how do you name a circle? All right, we have a triangle. We can name it by its vertices X, Y, Z. You got a rectangle. I can call it rectangle A, B, C, D because those were its vertices. Well, hi, I'm a circle. I don't have any vertices. So how do I name it? We name a circle by its center. All right, so name a circle by its center. All right, so for this instance, you see the center of the circle is C right here. So we're going to name this circle C, or you're going to see this notation probably in the homework assignment tonight. They do the circle symbol with the C. Okay, either way. Okay, either way. All right, first part, a diameter. Okay, a diameter is a segment. It's got 2 endpoints. Those endpoints are located on the circle. So here's one endpoint, here's the other. But here's the catch. With a diameter, you have to go through the center of the circle. Okay, a diameter must go through the center. Cut a diameter in half, and as most of you guys probably know, you got a radius. Radius is also a segment, but unlike a diameter, one endpoint has to be on the circle, the other one has to be the center. Okay, so that's the difference, all right? Diameter, both endpoints on the circle. Radius, one endpoint on the circle, the other's the center. Now, this might be a new term you guys haven't yet to be exposed to, which is a chord. It's a segment, just like a diameter and a radius were. They're segments. But now the 2 endpoints have to be on the circle, but it does not have to go through the center. Okay, if it does go through the center, then we call it a diameter. Okay, but a chord is just a segment where the 2 endpoints are on the circle. And just a little fact for you to impress everyone at dinner tonight, the diameter, which is also can be considered a chord, right? Because the endpoints are on the circle. It can be considered a chord. The diameter is the longest chord in a circle. Okay, so the diameter is the longest chord in a circle. No chord will be longer than it. Okay? All right. So I always like to relate what we're doing right now back to some old previous units. So can 2 circles be congruent? We know triangles can. We have 5 methods to do that. Well, can 2 circles be congruent? Yes, they can when their radii are congruent. Okay? All right, and just a little quick visual here. You don't have to copy this down, but if I have a circle with a radius length of 6 and a second circle with the radius length of 6, those 2 circles will be congruent if their radii are congruent. All right, what about if they're similar to each other? Well, what do we know about similar? We know corresponding lengths are in the same ratio, right? If corresponding lengths are in the same ratio. Well, think about a circle. What are really the only lengths we can measure? And we can measure diameters and radii, right? So let's say one radii is 5, while the other radii is 2. Aren't they always going to be in the same ratio? 2 to 5 is not going to change. It's going to be 2 to 5, 2 to 5, 2 to 5. I can draw another radii, but that's still going to be 5. I can draw another radii. That's still going to be 2, still 2 to 5. That's never going to change. What am I trying to get at here? All circles are similar. Okay, all circles are similar. Okay, all right, moving on. New vocabulary term, concentric. Bottom line, 2 circles that have the same center. So you got two circles that have the same center. Okay. Well, they can't be separated from each other, right? How am I going to do this? Well, that has this center. So how else could I draw another circle that's going to have the same center? You're darn right. I'm going to put it inside. Okay. So a tire wheel, a dartboard, bicycle wheel. All right. All concentric circles. A track. All right. If it was circular. All right. All concentric circles. Okay. All right. Some more vocab that we've had in the past that I want to bring up right now. Inscribed versus circumscribed. Okay. Inscribed versus circumscribed. So let's first talk about a polygon. When is a polygon inscribed? Well, inscribed, I always like to think the polygon is inside the circle. Okay, so if I do a quick diagram here. Now, here you go. Take a look at this bad boy. That's inside. Polygon's inside, but it's not inscribed. Okay, here's the catch. If it's going to be inscribed, its vertices must be somewhere on the circle. Okay, must be somewhere on the circle. Okay, so we say it's inscribed, and then we say circle. We say the polygon is inscribed, but I'm not going to do another diagram for this. All right, we can say the circle is circumscribed. So when I hear circumscribed, something is on the outside. Okay, so for this diagram I have just given you here, the circle is circumscribed around the polygon. The quadrilateral is inscribed in the circle. Okay, so the quadrilateral is inscribed, the circle is circumscribed. All good? Okay, here's the big chunk for today. The perimeter of a circle. Okay, the perimeter of a circle, also known as circumference. All right, there are two formulas. I'm not going to expect you to know both. Just know what you're comfortable with. C equals pi d, where d is the diameter of the circle, or you could do 2 pi r. 2 times pi times the radius, r for radius. Okay. Just for the purpose of these notes, I'm going to use c equals pi d. If you're a 2 pi r person, feel free to use 2 pi r. If you want to use both and get fancy with me, sure, go ahead. All right. Also, I always want to keep the jokes rolling, even though we're not together face to face. C equals pi d. Another way I've heard years ago. C, coffee, pi, D for donuts. Coffee, pie, donuts. That's how you can remember circumference if you want. Yeah, just let it roll off the tongue. It's good. It's good, I know. All right, you can thank me later. Coffee, pie, donuts. All right, so for number 1 here, find the circumference. Leave your answer in terms of pi. I'll talk about that in a second. All right, so I'm going to use my formula, C equals pi d. C equals pi. Now the radius is showing as 16. So the diameter, if I double it, has to be 32. Now, when it says leave your answer in terms of pi, that means you should keep the pi in your final answer. Don't go to your calculator and hit the pi button. Okay? So leave it as 32 pi, and usually the number goes first. Pi 32. Are you in honors? All right, we'll get the number going first. All right, so 32 pi. All right, next up. Diameter and radius to the nearest hundredth is the circumference. So now I'm giving you the circumference and I'm asking for the diameter and the radius. All right, you got it. So I'm going to start with C equals pi d. The circumference is on 106.4 equals pi d. I can at least solve for d here, right? By doing what with pi? How can I get the pi out of there? I can divide both sides by pi. All right, so d equals, and there's rounding directions here, nearest hundredth. So if you guys go to your calculator right now, I'll get mine out. And I end up with 106.4 divided by pi button, everybody, is second, and then you got to use the caret button. All right, so second, the button right above division there, divided by pi. All right. and then round that to the nearest hundredth. And we should end up with, what do I have here? 33.87 millimeters. Okay, then I go to radius. Okay, radius is half the diameter. So I'm going to cut the diameter in half and end up with, now again, let me go to this point here. That's the diameter, rounded though. That's the diameter rounded. When I find the radius, I want to go back to my calculator and divide that number because it's going to get more exact. So I'm going to divide that number by 2 and then round that to the nearest hundredth, 16.93. Okay, so if you're going to cut it in half, go back to your calculator answer and cut that one in half, not the rounded answer, if you can. Okay, hopefully we're doing all right, chugging right along. Ooh, now we're going to get serious here. You got a square with a side length of 9. Can I do a square here? Oh boy, one job. Good enough. Nice. Okay, I got a square that's got a side of 9 inches. Is inscribed in circle J. Oh, I wish I knew that to begin with. All right, here we go. Now we're going to get nuts. Should have read the question before that, but we're good. Here we go, kids. It's inscribed in circle J. So remember, inscribed touches each vertice. Yep, laugh later, laugh later. There you go. There's the circle. And it's got a side length of 9, remember? Boom. What's the exact circumference? And I'll talk about exact. All right, so you're asking me for circumference. I'm doing 2 pi. No, I'm not. You're lying. I'm doing pi d. Okay, so I need to find the diameter somehow. Okay, I need to find the diameter. Now, we can draw in one if we want. That's not going to be helpful. There's no way I'm finding that bad boy. Scrap it. I could find that diameter. No good. Scrap it. Okay? Think about it. Pause the video right now. Is there a diameter you can draw in your diagram right now that maybe you could find? All right? Think about it. Okay? I'll give you guys a couple moments here. Pause the video if you need. Okay? What diameter could you draw in that possibly I could find? Okay, hopefully you're thinking about a diagonal of the square. A diagonal of the square is the same as the diameter of the circle. Take a look. All right, so if you can find that, that's your diameter. Okay? So let's talk. How can I find it? Well, it's a square. I know that's 9. Every side's 9. What about the angles, kids? What do I know about the angles? Oh, they're right angles. Oh, so you're saying I have a right triangle here. I have a right triangle right here where I know 2 of the sides and I'm trying to find the hypotenuse. Okay, you know what the deal is, right? You know what the deal is. Here we go. 9 squared plus 9 squared equals c squared. $162. Oh, you know what my next question is. What class are we in? You've missed it. What class are we in? Honors. Break that sucker down. And it shouldn't be that big of a deal because you already found the perfect square up above. It's 81. So it should be square root of 81, square root of 2. So it's 9 square root of 2. Okay, there's your diameter. Let's go back, plug it in. Pi times 9 radical 2. Okay, exact. Exact circumference means no decimals, please. So I do not want you typing that into your calculator. You can leave it as 9 radical 2 pi inches. Okay? Everyone good? All right, there's a way. You can find a way. All right, find a way. Next up, circle Q has coordinates. Yep, passes through there. What's the length of the diameter? Woo, buddy. All right, let's get a little peek at what this looks like. So if you guys want to graph it, stop the video and graph this, go ahead, stop it. I'm just going to get my lines out here. Okay, so I got 3 net 1, 2, 3, negative 2. That's the center of circle Q. So that means I'm going to call that Q if that's the center. And then 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. R. Okay. So it wants to know what's the length of the diameter of this circle. Okay, so Q is the center, R is a point on the circle. Well, hold on a second. If I connect those, what's that called if I connect them? Isn't that called the radius? And what's the relationship between the relationship between the radius and the diameter? Diameter, if I could speak, what's the relationship? Diameter is twice the radius. So if I can find the length of QR, I'll double it and get the diameter. The length of QR, yeah, buddy, here we go. Distance formula. You guys want to stop the video and try it on your own? I recommend it. Okay, I'll do my work here. And then when you come back, hopefully we got the same answer here. So I got the length of QR to be 5. So the diameter will be equal to 10. There we go. Good work. All right, one more and we'll call it a day. Find the circumference. Leave your answer in terms of pi. I'm going to let you guys stop the video right now. All right, and all I am going to do, I'll do the work too. All right, and then restart the video myself. Okay, so pause it, see what you can do. Okay, real quick here, guys. I drew a diagonal in, which also acted as the diameter of the circle. Similar like we did with the square problem a couple problems ago. I did Pythag to find the length of the diagonal. And then I found the length of the diagonal to be 10, plugged it into circumference equals pi d. The direction said leave your answer in terms of pi, so I left the pi in my answer and got the circumference to be 10 pi. 10 pi. Okay, so now you guys are on to the assignment. It is out of the textbook. If there's an issue because you forgot your logon and you don't have an actual book with you, please contact me through email and I will get a picture of that page 701 to 703 to you. And then Wednesday's Google Meet, bring all your questions. All right, take care, everybody.